Hi, for this video we're going to be discussing Chapter 6, which is on memory. As always, the PowerPoint slide starts with our student learning outcomes and a definition of what it is we're going to be talking about with memory. The memory process is something that's really important to understand, so I have a graphic here explaining that, where we have incoming sensory information coming in, and we get that from all around us. We encode that information for storage. We store it in some way, and then eventually we retrieve it. So those are kind of the big important parts of the memory process. At any part of this process, though, we can have one of these things fail. So you could not pay attention to something coming into your senses, you could not store it correctly, or you could have difficulty retrieving it. If at any point we have a failure there, then memory fails. So then you can't pull up the information when you need it. So I know for me, I'll have a lot of incoming sensory information that's lost. So I just won't pay attention to things and kind of be in my own world, and then I never encode that information, and then I can't remember it later. So you can have a failure at any point along this continuum. I really love Inside Out as a metaphor for memory. So if you haven't seen Inside Out, it's a great one to kind of see. But each of these little balls here are one of the character's memories. And so you can kind of see this idea of memory being short term. So they keep all the memories, the recent memories in her head. And then there's a long-term storage where they keep all these memories pretty much limitless in a different part of the brain. So it's a really interesting metaphor. Not exactly accurate, but still really interesting as a metaphor. The three-stage model is what we're going to spend a lot of time on for memory. So with this, make sure you can understand the differences between sensory memory, short-term working memory, and long-term memory. So that's how we split up this model of memory. And memory can be a little bit confusing to people because when we're talking about things like sensory, short-term, long-term memory, we're not talking about things that I can point to easily and say, here's the sensory memory, here's the short-term memory. It's not necessarily something that we can map onto a direct part of the brain. More, we're talking about a model for this. So kind of a metaphor of what might be happening in the brain, or a model of what might be happening with our memory processes. So the next few slides for this are going to break down the differences between sensory, short-term working, and long-term memories. So with sensory memory, this is information that's kind of about what's happening in the world, so you're pulling it in from your senses. There are subtypes for each, so this is your visual. Sensory memory is the iconic memory, your auditory is the echoic. So if you've ever had somebody say something to you and you maybe cross the room in your house and you're like, what? Oh yeah, it's on top of the fridge. So you don't think you've heard it, but then you can eventually report on what you heard. That's because you're pulling it back out from this echoic memory. So it was in there. It was in your sensory memory, but it might take you a minute to pull it back out. I know I do that all the time. Short-term working memory, what we're talking about there is kind of this workplace or this gym. That's what I think of it anyway, as a gym or a exercise facility where you've got sensory memory, long-term memory, all coming together, and it's working and going. So one way we try to keep information in our short-term working memory is maintenance rehearsal. So we might remember, if I give you a phone number, if I say remember 555-7238, then you might sit there to yourself and go 555-7238, 555-7238, 555. So you're trying to just repeat it to remember it. The capacity of short-term memory. So we think of how much information can we keep in this workplace. And we think the magical number is 7 plus or minus 2. So you can keep 7 bits of information plus or minus 2, so maybe 5 to 9 bits of information. But what we end up doing is if you try to remember a big string of letters or numbers like that up here, F, bit, waka, I, B, M, E. So you might try to remember this nonsense word. What we often do to this nonsense word is chunk it. So we would take it and chunk little bits together. So you'd end up with FBI, TWA, CIA, IBM. Or in case of phone numbers or social security numbers, we chunk little bits. If you can't chunk it, then the true magical number seems to be more 4, to be about 4 plus or minus 1. So we end up with, if you can't chunk it, then we often chuck it. So that's why we really have these phone numbers and dates and all this social security number, credit card number in these little chunks. Oh, yes, and at the bottom of this slide, if you want to kind of see how this happens when you can't chunk and how we lose this information, there's a little demo down there that's linked in the slides if you're interested in that. Comparing short-term memory and working memory. So we often do kind of use these terms interchangeably, short-term memory, working memory. But really with working memory, this is more of an active, conscious manipulation. So with working memory, we're kind of doing work, trying to maybe solve math problems, define something. Short-term memory is often thought of as more simplistic. So it's just kind of in there, but and it's what you're thinking of at the current moment, but maybe not this active, conscious process, this kind of doing work process. The Baddeley model of working memory. Again, a lot of these models of working memory can give people some trouble, or of memory in general, not just working. They can give people some trouble because this isn't something where I can again point and say, here's your visuospatial sketchpad. Here is your central executive. It'll probably be up here, actually, but we can't really do that. This is more of a model or a metaphor. But for working memory, Baddeley said that we had 3 components. We have this visuospatial sketchpad, which is really oriented to visual, pictures, spatial information. We have the central executive, which kind of makes these decisions, bringing in information from long-term memory and from the visuospatial sketchpad, and the phonological loop. With the phonological loop, we're talking more about some of this information like we've got here, so these directions, kind of more of a verbal material than visual. So the visual material is coming out of the visuospatial sketchpad, verbal more out of the phonological loop, central executive is kind of taking all this information, pulling in more information from long-term memory, and helping to make adequate decisions. For long-term memory, a lot of people think that long-term memory is more of who you took to senior prom or the name of your first dog, but really things get into long-term memory if you remember them longer than approximately 20 seconds or so. We think long-term memory has an unlimited capacity. If you really want to get things into long-term memory, just rehearsing them, that maintenance rehearsal is not going to do it. So we'd say instead to use elaborative rehearsal, and here's some ways that you might be able to do that. Things like generating examples, putting it in your own words. This graphic looks confusing, but really what it's showing is the memory process. So it starts with sensory memory, all right, kind of pulling in info from the senses. Shows how this, if you pay attention, it gets into short-term memory. And some of these other little things on top and bottom kind of give you a little bit more detail about what's happening there. And then if you encode and store this correctly, it gets into long-term memory where it can be retrieved. So I think this graphic's super, super helpful to kind of put all this together. Information in long-term memory. We have some different ideas of how information is stored in long-term memory. So the first is that it might be stored with this explicit or implicit memory. So explicit memory is things you can recall easily, things like your where were you on 9/11? You can recall that easily, and that's something about you. You've experienced that. So that's an episodic memory. Semantic memory is general knowledge and facts. How many tires are on a car? And then we have implicit memory. So this is a little different from explicit. With implicit, you can't say how you know it. So this might be something like, how do you tie shoes? I know when I was trying to teach my kid how to tie shoes, it's not easy for me to remember. I can do it easily, but I can't remember how to tell her exactly what to do. So for many of us, this is things like maybe folding a paper airplane or riding a bike. We can do it, but it's hard for us to say how. The next slide, you can kind of work through and think about what types of memory these might be getting into. Organization and long-term memory. Another idea is that we might take our long-term memories and and kind of cluster them. So we put these related items into categories. So if you look at this graphic, you can imagine what you might put together. So maybe fruit, furniture, and methods of transportation. So we'll take those related items and organize them in our brain to help us remember them better. Another idea of how we remember things in long-term memory is this model here. So if I say something to you like animal, animal's at the top of this graphic, and according to the semantic network model, the word animal might trigger many other thoughts in your brain. So it might be like has skin, can move around. It might then go into bird or to fish, and then maybe into some subcategories of bird or fish. We're going to spend most of the rest of our time talking about ways that memory can fail. So one way that we often remember things are through retrieval cues. So if you were trying to remember this guy's name, I might give you some cues, such as finger looking good, chicken, Kentucky, 8-piece meal, and you might be like, oh, yeah, Colonel Sanders. So I'm trying to help you to retrieve this information. But we end up with a lot of glitches or problems when we try to retrieve stuff. So we probably all had this experience of information being on the tip of the tongue. We know it's in our long-term memory, but we can't retrieve it. We also have something called a serial position effect, where we can remember things in the beginning of a list and the end of the list, but we really struggle with the middle. Christina Aguilera had this experience with the national anthem. There's a link to that, but she kind of got the beginning, the end really strong, but then kind of botched the middle part. We also have some ways in which encoding is a little bit specific. So the context effect, this effect is saying that the retrieval is better in the same setting as encoding. So if you kind of learned everything if you go through and do all the material for this class at your desk, you'd do better on an assessment than if you sat at that same desk rather than if you sat at a busy Starbucks. So if you're in the same setting as which you encoded something, your retrieval might be easier. Mood congruence is also an interesting idea, and I know I experience this a lot. So you recall more information relevant to your mood. So if you're in a good mood, you can recall times you're happy. If you're in a bad mood, you recall times you're upset. And a really, really important part of this unit, though, is to understand that memory is not perfect. We do have these things called flashbulb memories where we feel like we can remember everything. For some people, this might have been something like 9/11. But these memories, we know they decay like normal. They're not really more accurate. Ebbinghaus showed us that we kind of forget information. Forgetting is this inability to retrieve it. He remembered all of these nonsense syllables and then tried to keep himself able to remember all of these nonsense syllables. So things like ROH, LES, or LAZ, really, really difficult to just remember strings of these syllables. And he found really that he forgot most of these syllables right away, but the ones he retained he kept. So he taught us a lot about this process of memory and forgetting. Why do we forget? For many things, we just fail to encode it. So if you forget who's on a $5 bill, a $1 bill, $10 bill, it's not because you haven't seen these, it's because you didn't really encode it. We also have decay, so our memory just fades. And then interference, so you can kind of read this retroactive, proactive interference difference. We can also be motivated to forget, so we can suppress information. That's a conscious decision to kind of forget. Or we can repress it, which is unconscious. This is a little more controversial. One thing we know about memory is that it is imperfect. We actively construct our memories, and therefore our memories can be changed. So Dr. Loftus, a psychologist, did a lot of work with imperfect memory, and she found that if you ask people who witnessed a car accident, how fast were the cars going when they contacted, when they bumped, when they smashed, when they collided, that you'd get a lot of different answers when asking this question. We also know that eyewitness testimony, so memory of watching a crime happen, can be really, really unreliable. So I would definitely encourage you to read this and to watch this video, Picking Cotton, which is what they entitled their book, about eyewitness testimony, but it's notoriously unreliable. The last topic is on memory in the brain. So we know with neuroscience research that complex memories are really distributed throughout the brain. Definitely review Alzheimer's disease. We see these abnormal structures proliferate, and when they do, we see memory getting worse over time. So this does tell us that memory is kind of a function of the brain. And finally, review retrograde, anterograde amnesia. So this also gives us information about memory. Bye!